In this video, I wanted to look at some very basic applications of algebra of solving equations. And really, this is kind of the idea of what the point of math is in algebras in general. So if we have a real problem, how can we actually write an equation to solve that? And then we can use the algebraic strategies that we've been talking about to actually then solve it. Or it's kind of like, how would we write a formula? How do we actually create an equation to help us solve something? And there's some basic problem-solving strategies in the packet on the last page here, which is kind of like algebra basics, which is again kind of a review thing, but it's an important part of it. So some of the strategies, just to review, it says choose a variable to represent the quantity you want to find. So typically, if you're trying to solve a problem, there's like something it's asking for, and that's usually what you want to let be x. Or you can use a different letter. You can use whatever letter you want to stand for, but usually that's the point. I want to figure out a variable, and then I want to write an equation. And often it can be helpful to draw I would amend what it says here. It says draw a picture. I would correct that and say diagram. A picture is like, a tree in a farmhouse and whatever. It's like something pretty that is like a picture of something real. A diagram is like a mathematical, like say for example, shapes or parallelograms or whatever. An actual mathematical diagram is something which is correspondent to the problem, which is there to help us understand the relationships between the quantities in the problem. But basically sometimes it's helpful to draw a diagram to help us understand how can we actually write an equation. Like sometimes we might draw a picture and it will help us realize, okay, this is a rectangle, so I could use this formula, or it's a circle, I could use this other formula, something like that. And then it says to write an equation to model the situation and then solve it and make sure your solution makes sense. So like this makes it all sound very simple, but really writing the equation is often the hardest part. And once we have the equation, we can then just solve it. Usually that's the easier part in most cases, unless the equation is really, really hard, of course. So let's look at a sample problem. It says to receive a degree in child development, students at Dirk College must complete 135 hours of volunteer service by working 3-hour shifts. If a student has already volunteered 87 hours, how many more 3-hour shifts must they work? And now you can probably figure out the answer to this without writing an equation, just by kind of common sense thinking, okay, well, how plus 3 plus 3 plus 3 plus 3, how many times I got to do that, and so on. But our goal here is to actually create an equation, use an equation. So we're going to solve it that way because that's the whole point. And usually that actually makes it easier and makes us more certain that we have figured it out. And so how do I write the equation is the first part. And what should our variable be? But basically what I would choose for my variable is looking at what it's asking for. How many 3-hour shifts do we need to work? So basically that's what I would always assign to be x. And like the goal in solving an equation is finding out x. So once I have x is equal to this, I'm going to have the answer to my word problem at the end of the day. And so I want to know how many 3-hour shifts am I going to need to work. And basically, I would try to write an equation using all the other information that I have. I know that I need to complete 135 hours of volunteer service by working 3-hour shifts. So if x is the number of shifts, and it's often helpful to actually write out what does x represent in the context of your problem, but x is assigned to be the number of 3-hour shifts. And usually on an exam, it is smart to label, what your variables stand for. Usually it's implied, and it, if it's obvious, you don't need to do it. But in a more complex problem where you have lots and lots of different things you're trying to solve, it's very important. Or you could just use S for shifts, and that would be more obvious. But we want to make sure we're using the rest of the information that we were given, which is, well, we have to complete this amount, and we've already volunteered this amount. So usually I would think about my equation in such a way. It's like I could start with how many hours I have worked. And again, there's more than one way you could do this, but this is just how I would approach it. I have currently worked 87 hours, and I need to add more hours on top of that. I need to put in a bunch more shifts to get to it. And my goal is to make a total of 135 hours to finish my my volunteer service. And really, you could think about it as like this would be a common error in writing the equation as 87 plus x, because x is, well, if I wrote this equation, this would tell me how many hours do I need to work to solve this. Because if I'm thinking about the units that are going on in here, this is 87 hours, this is 135 hours. So I could think about, well, how many more hours do I need to add on to get to 135? And that's cool. But notice that I'm not trying to figure out the number of hours, I'm trying to figure out the number of shifts. And basically, this is a pretty easy transition because each shift counts for 3 hours. So basically, if I take 3 times x, every one shift counts for 3 hours. So if I think about this, and really this is just something that I knew was going to happen because I'm trying to find the number of shifts, and I know each shift is worth 3 hours. So if I take 3 times the number of shifts, that will give me the hours. So this would be the hours I started with. This would be the hours completed per shift, right? Because each shift is 3 hours, and you get a total of 135. And from here, I would just need to solve, well, so how many shifts do I need? Because for each, every shift is going to add on 3 more hours to my needed amount. And so now I just have an equation. Now I just need to solve. So since I have numbers on both sides, I would subtract 87 to both sides, leaving me with 3x is equal to 48. Assuming I did that correctly. For some reason it seems off, so I'm just going to double check with my calculator. It has been a long summer, and my basic math, I'm very good at doing it in my head, but when I'm a little rusty, I tend to not trust myself, so we'll go ahead and check just in case, but we're good. And then I would need to divide by 3 to finish isolating x, which would be 16 times 3 is 48. And so what that tells me is I need to work 16 shifts, or I could always, another smart thing to do with a word problem is to answer it using a complete sentence. It's kind of like I want to answer it in the same way I was asked it. That way no one's going to be confused, because not everybody necessarily knows algebra and knows what that would mean. But so you could then translate it to a complete sentence. I need to work 16 shifts to finish, or something like that. And that's something like, I don't think you necessarily need to do that on the exam, because it's kind of a waste of time for all of us who know algebra. But if you can see my point, it's a good habit when solving real problems to do this. And anyways, that's the whole point of the algebra, is we can take a real problem, write an equation, use the equation to solve it. But usually, actually solving the equation isn't as hard as actually how do I come up with a sensible equation. And that's part of something. It just takes practice. And I wanted to give you some tips, like in terms of how do I get started and how would I actually do that. So, and it's sort of like thinking about an equation. What do I have? What's my goal? This is equal to this. And it's like, this is what I started with. This is how much I need to add. And this is how much I need to end up with. So how much I started with plus how much I add needs to make how much I end up with. Stuff like that can often come in handy.